Now A can fill it in 5 hours, B can fill it in 10 hours, C can empty it in 20. So 1 upon 5 plus 1 upon 10 and minus 1 upon 20, because filling is positive work, then emptying is negative work, minus 1 upon 20. This is the amount of work they are doing together in 1 hour. And therefore, if they are taking k hours to complete the work, then k into this sum should give us 1, the amount of work that we have assumed. Now just solve it for k. That's also quite straightforward. 4 plus 2 minus 1 is equal to 1. So k turns out to be 4. That's the right answer. Look at the next one now. Here, emptying the tank is positive work and therefore filling would be negative work, and the tank is 2/3 full, so the amount of work to be done is only 2/3. Right? If it were to be filled, if it is 2/3 full, then the amount of work to be done would have been only 1/3. Now 2/3 of the tank is full, 2/3 all of it has to be emptied. So the amount of work to be done is also 2/3. So we'll not equate it to 1 this time, we will equate it to 2/3. And the amount of work that these taps do together is 1 upon 24 being positive work, plus 1 upon 6 being positive work, and minus 1 upon 12 being negative work. And all of this into k shall be equal to 2/3, the amount of work that needs to be done. Solve it for k. 24, 1 plus 4 minus 2 is equal to 2/3, 8. So this turns out to be 16 upon 5 minus 2, 3. That is 5.33. So 5 hours and 20 minutes. That's the right answer. Look at this one now. Please pause the video, do it yourself. This is a very good question. This is one of my most favorite questions. I've been giving this to the students for several years now. Please don't take it lightly. Do your best. Please pause the video and do it yourself. There is a lot to be learned from this question. Tap A can fill in 10 hours. So 1 upon 10. B can fill in 20, so 1 upon 20. C can empty in 30, so minus 1 upon 30. So it turns out to be 7 upon 60. 7 upon 60 is the amount of work they would do in 3 hours. That is important to understand, because the taps are not working together, they are working one by one. So 7 by 60 is the amount of work done in 3 hours. The amount of work that practically needs to be done is only 3/4, so 3 by 4. So to just make the base common, 3/4 or 45 upon 60 is the amount of work that needs to be completed. Now we can't apply the simple unitary method, because that would apply when all the 3 were working together. Here they are working one by one. So when the tank actually fills up, only one of the 3 taps will be operational. Okay, so we can't apply the typical unitary method. We have to bring this closer to 45 by 60 and then check that which tap will be in action. So 7 upon 60, if we have 6 such cycles of 3 hours each, we will get 42 upon 60. So 42 upon 60th work has been done and 6 cycles of 3 hours each have been completed. So how much work is remaining? 3 upon 60 work is remaining, which is equal to 1 upon 20. And whose turn is it now? 6 complete cycles have been completed. So it is the turn of A. A would complete 1 by 10th work in 1 hour, but only 1 by 20th work is remaining, and therefore A would take another only half an hour. So in all we have 18 hours. 3 into 6, 18 hours here, plus half an hour here, 18.5 hours starting from 7 AM. So the tank would begin to overflow at 1:30 AM. That's the right answer. This was the concept, guys. GMAT shorts are deliberately kept brief. For an elaborate explanation, please refer the stage 1 videos. Thanks for watching.